Hello students, today I am going to give you a lecture on general equilibrium theory. In economics, general equilibrium theory attempts to explain the behavior of supply, demand and prices in a whole economy with several or many interacting markets by seeking to prove that the interaction of demand and supply will result in an overall general equilibrium. General equilibrium theory contrasts to the theory of partial equilibrium, which only analyzes single markets. A general equilibrium is defined as a state in which all markets and decision-making units are in simultaneous equilibrium. A general equilibrium exists if each market is cleared at a positive price, with its consumer maximizing satisfaction and each firm maximizing profit. Under this general equilibrium model, I shall talk on the Walrasian general equilibrium model. The most ambitious general equilibrium model was developed by the French economist Léon Walras, 1834 to 1910. In his Elements of Pure Economics, Walras argued that all prices and quantities in all markets are determined simultaneously through their interaction with one another. Walras used a system of simultaneous equations to describe the interactions of individual sellers and buyers in all markets. And he maintained that all the relevant magnitudes, that is prices and quantities of all commodities and all factor services, can be determined simultaneously by the solution of this system. In the Walrasian model, the behavior of each individual decision maker is presented by a set of equations. For example, each consumer has a double role. He buys commodities and he sells services of factors to firms. Thus, for each consumer, we have a set of equations consisting of two subsets. One describing his demands of the different commodities and the other his supply of factor inputs. Similarly, the behavior of each firm is presented by a set of equations with two subsets. One for the quantities of commodities that it produces and the other for the demand for factor inputs for each commodity produced. The important characteristics of these equations is their simultaneity or interdependence. In a general equilibrium system of the Walrasian type, there are as many markets as there are commodities and factors of production. For each market, there are three types of functions, that is the demand functions, the supply functions, and a clearing the market equations, which stipulates that the quantities demanded be equal to the quantity supplied. A necessary but not sufficient condition for the existence of a general equilibrium is that there must be in the system as many independent equations as the number of unknowns. Thus, the first task in establishing the existence of a general equilibrium is to describe the economy by means of a system of equations defining how many equations are required to complete and solve the problem. Even if there is equality of independent equation and unknowns, there is no guarantee that a general equilibrium solution exists. The proof of the existence of a general equilibrium solution is difficult. Now we shall come to graphical treatment of the two-factor, two-commodity, two-consumer, that is 2 into 2 into 2 general equilibrium model. A general equilibrium system involving two factors of production, two commodities and two consumers is termed as 2 into 2 into 2 model of general equilibrium. Assumptions of the 2 into 2 into 2 model. Number 1. There are two factors of production, labor L and capital K, whose quantities are given exogenously. These factors are homogeneous and perfectly divisible. Number 2, only two commodities are produced, X and Y. The production functions of the two commodities are represented by two isoquant maps with the usual properties. Number 3, There are two consumers in the economy, consumer A and consumer B, whose preferences are represented by the ordinal indifference curves, which are convex to the origin, exhibiting diminishing marginal rate of substitution between the two commodities. Number 4, the goal of each consumer is the maximization of his own satisfaction, that is maximization of utility subject to his income constraint. Then number 5, the goal of each firm is profit maximization subject to the technological constraint of the production function. Number 6, the factors of production are owned by the consumers. Number 7, there is full employment of the factors of production. Number 8, all incomes received by the owners of the factors of production are spent. Number 9, there is perfect competition in the commodity and factor markets. Number 10, consumers and firms pursue their goals faced by the same set of prices, that is price of X, Px, price of Y, Py, wages W, and R, rental of capital. In this model, a general equilibrium is reached when the 4 markets, that is 2 commodity markets and 2 factor markets, are cleared at a set of equilibrium prices, that is Px, Py, W, and R, and each participant economic agent, that is 2 firms and 2 consumers, is simultaneously in equilibrium. Static properties of general equilibrium state. 3 static properties are observed in a general equilibrium solution reached with a free competitive market mechanism. Number 1, efficient allocation of resources among firms, that is equilibrium of production. The general equilibrium of production occurs at a point where the marginal rate of technical substitution, that is MRTS, between the 2 factors is equal for all firms. This efficiency in factor substitution implies allocation of the factors among the 2 firms, which can be written as MRTS Lk of X equal to MRTS Lk of Y, which means that marginal rate of technical substitution of labor and capital for commodity X is equal to marginal rate of technical substitution of labor and capital for commodity Y. Number 2, efficient allocation of the commodities produced between the 2 consumers, that is equilibrium of consumption. Here, the marginal rate of substitution, which is signified by MRS, between the 2 goods is equal for both consumers. This efficiency in distribution implies optimal allocation of the goods among consumers, which can be written as MRS XY of A equal to MRS XY of B, which means marginal rate of substitution of goods X and Y for consumer A equal to marginal rate of substitution of good X and Y of consumer B. Number 3, efficient combination of products, that is simultaneous equilibrium of production and consumption. In this case, the marginal rate of product transformation, that is the slope of production possibility curve, be equal to the marginal rate of substitution of the 2 commodities between the consumers. It implies optimal composition of output in the economy and thus optimal allocations of resources, that is MRPT, that is marginal rate of product transformation of good X and Y equal to MRS XY of A, that is marginal rate of substitution of good and X and Y of consumer A equal to marginal rate of substitution of good X and Y of consumer B. So these 3 are equal in this case. These 3 properties are called marginal conditions of Pareto optimality or Pareto efficiency. A situation is defined as Pareto optimal or efficient if it is impossible to make anyone better off without making someone worse off. Next we come to existence, uniqueness, and stability of an equilibrium. 3 problems arise in connection with a general equilibrium. Number 1, does a general equilibrium solution exist? That is the existence problem. Number 2, if an equilibrium solution exists, is it unique? that is the uniqueness problem. Number 3, if an equilibrium solution exists, is it stable? That is the stability problem. This can be shown with the help of a diagram, that is the diagram of unique stable equilibrium. An equilibrium exists when at a certain positive price, the quantity demanded is equal to the quantity supplied. The price at which QD equal to QS, that is quantity demanded is equal to quantity supplied, is the equilibrium price. At such a price, there is neither excess demand nor excess supply. The equilibrium is stable if the demand function cuts the supply function from above, and it is unstable if the demand function cuts the supply function from below. The uniqueness of equilibrium is related to the slopes of the excess demand functions, that is, the curve which shows the difference between quantity demanded and quantity supplied at any one price. Now we come to the conclusion of the general equilibrium theory. General equilibrium theory, despite its obvious shortcomings, is the most complete existing model of economic behavior. General equilibrium theory, by viewing the economy as a vast of mutually interdependent markets, makes the student aware of the tremendous complexity of the real world. At its present stage, general equilibrium theory is largely non-operational and unrealistic. However, the general equilibrium model can be improved so as to become more flexible, more realistic, and hence more useful for analyzing the real world. Thank you.